This is a rather challenging question on the Newton-Raphson method. So let's start trying to make sense of it. You're given a graph with f and g shown. You're told that they're defined for x is greater than or equal to 0. Well, do you know what? I don't like having all this text. It doesn't make it clear what's relevant and what's not. So let's cross some of it out and just pick out some key details. I'm going to acknowledge that x has to be positive. You can see that from the graph anyway, but let's just write that there. It might come in useful later. And I'm going to cross out this information because it doesn't tell us anything that isn't already on the graph or already known. We're also told that the equation fx equals gx has exactly one real root. Well, we can see that on the graph. They cross once, and so the x value of that must be alpha. So I'm going to indicate that on and then cross out that information. Again, I don't want to have to read that again because I know that there's nothing useful there. So I've just stuck alpha there on the graph. Now, read part A carefully. Show that alpha satisfies this complicated looking equation. That's a really long-winded way of saying start the process of finding the value of alpha. To show that alpha satisfies something basically needs us to start trying to find out something about alpha. And of course alpha is where fx and gx meet. It's simultaneous equations. How do you find the intersection of two curves? Well, you set f of x equal to g of x. So let's do that. Now I'm going to take the expressions from the question. F of x equals g of x. I'm going to get rid of the big fraction by multiplying by its denominator. And at this point, we spot that we've got a power minus 2x, but in the thing we're trying to work towards, it's just power 2x. So what to do to the equation to sort that out? Well, you need to acknowledge or notice that e to the power minus 2x simply means 1 over e to the power 2x. So I'm going to multiply through this equation here by e to the power 2x. It's going to cancel it out here, and it's going to turn up on the left-hand side. And then you've done it. Just move that term over to the right. So that's that. I don't need to talk about h of x and etc. I've created the equation that they want, and maybe a conclusion is in order, but in this case I think you get all the marks for just stopping there. So part B, hence show that Newton-Raphson gives you this iterative formula. Well, look in your formula book, and the Newton-Raphson method is given by that expression there. So we need to work out what f of x is and f dash of x. Well, Newton-Raphson, for solving this, means that you've got f of x equals 0. So there's that 0. So this thing here must be f of x. So if that's f of x, we should write down what f dash x is. And a big mistake that people tend to make with a question like this is they start immediately trying to substitute things into this formula. But you should make sure you've got all the building blocks in place before you go near a big formula like this. We've got the numerator. We don't yet have an expression for the denominator. So let's get that first. And then you just do one thing at a time. Because if you try and stick it all straight into the formula, you tend to forget that we need product rule to get the correct derivative, f dash x. So what is this first derivative of f? Let's just copy what f is over there and then differentiate it term by term. Well, x squared becomes 2x, 3 doesn't contribute anything to the derivative, and then we've got a product rule situation for the last term. So I like to think of this as it's the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. So the first thing is x times the derivative of the second thing. Well, if you differentiate e to the 2x, you get 2e to the 2x. So our first term is going to be 2e to the 2x times the x. And then plus, and then we're going to have e to the 2x times the derivative of x. Derivative of x is just 1. So plus e to the 2x. And you'll notice I've been careful to use brackets because we're subtracting that product in f of x. So therefore we're subtracting everything from the product rule in f dash x. And I'm actually then going to write that slightly differently. So you'll see that I've factored out an e to the 2x out of these two terms and stuck it there. But the only reason I've stuck it there is because if you look carefully, look at the denominator here. Look, that's the form we want our denominator in. 2x minus 1 plus 2x, lots of e to the 2x. That's exactly what we've got here. So now I can go to my Newton-Raphson formula. And I'm going to take, just to make it a lot easier to do the algebra, and the algebra here is hard, I'm going to ignore the xn's here and here. I'm just going to get rid of all that and just deal with x for a while. So it's x take away, our numerator is f of x, and our denominator is f dash x, the last line of purple writing there. Right, now let's look at what we're trying to create. Look at this. What's different about this from this whole thing here? Well, look, they've got it all as one single fraction, whereas we've got x take away this fraction. So we need to combine it into a single fraction. For that, we need a common denominator. So I'm going to, in fact, if you think of this as x over 1, then I need to times top and bottom of this fraction by this whole thing here. So x lots of that denominator. And then I'm taking away all of this numerator. So notice I'm dealing with the signs carefully. So we're taking away x squared, we're taking away 3, and we're taking away negative x e to the 2x, which is why the signs have gone a bit funny here. This is why this is a hard question, because there's a lot of little things where you could go wrong. The denominator we know. And then we need to somehow show that this numerator here is equivalent to this numerator here. And if you just simplify and be careful with it, it works. So I've sort of expanded out that left-hand bracket. You can check this yourself. You can just trust me for now and just gloss over this, but you need to really practice this algebra. It'd be a really good thing to practice this algebra in your own time. So once you watch this video, just try and do this whole thing from memory. That's how you cement things in your brain and you practice getting it out of your own brain, which is the main skill that you're using in an exam. We can cancel a few terms out there and then we get what we want. Now, I wouldn't leave it like that. Remember, we didn't deal with we left the little n's out at the beginning, so we need to put those back in now and then put the x n plus 1 at the beginning. So x n plus 1 equals, and I've stuck all the little n's in wherever there's an x there. And we're done. Now, for part C, we need to use this iterative formula. Well, I'm just going to clear a bit of space because we don't need any of that anymore. We've got the formula we need here. And we need to, it does say to use a suitable initial value. Well, I'm going to use 1 because we can see that our root is very close to 1. And you can sort of see from the diagram that's what they're hankering after you choose it. You can get away with using like 0.8 or something sensible. It probably works for about 0.5 as well. It might work for other numbers. But 1's the most obvious one to use, and that's actually the one that's listed in the mark scheme. You don't really want the examiner to have to get the calculator out if you can. Excuse me. So x naught is 1, and if you stick that in the formula here, you get x2 out. Sorry, or x1. You might have called this x1 equals 1. I tend to start with 0. Doesn't matter. Now, big tip. What you should do is, in your calculator, if you're starting with 1, clear the display and type 1 equals. By doing that, you've saved 1 as the answer button. And then if you key in this whole expression here, using the answer button wherever there's an xn, then you can just keep pressing equals and it'll generate the next few terms. So answer squared times brackets 1 minus 2 e to the power 2 times answer, close brackets, etc., all the way through. And eventually you get the next value comes out as roughly 0.8319. I'd write down several decimal places if I were you. Don't ever clear the display, because you just press equals again and it'll generate the next one. Press equals again and it'll generate the next one. Press equals again and it'll generate the next one. You can see that it's converging to this 0.770. And I'll do one more time to convince ourselves that that is where it's converging to, and that's fine. You're looking to do it to 3dp, so that seems to be where it's converged. So our answer is 0.770 to 3 decimal places. And then part D, which is quite different from A, B and C. A, B and C is all about really sort of setting up and then using the Newton-Raphson method, whereas part D is kind of a functions question. So f of g of x is what we're asked about. F of g of x, and it needs to equal 2/13. So let's first work out what is f of g of x. Well, it's asking us to put g of x in, this expression here, as an input into the f function. So we've got g of x on the top and then g of x squared plus 3, which gives us this: e to the minus 2x on top and e to the minus 2x all squared plus 3 on the bottom. In this arrangement you multiply the powers, so let's do that. And then remember from before, e to the minus 4x just means 1 over e to the 4x. And similar with e to the minus 2x. So I'm going to multiply top and bottom of this fraction by e to the 4x, because that's going to get rid of these negative powers, which I don't really like. And by doing so, we get e to the 2x on top and 1 plus 3 e to the 4x on the bottom. Now might be a good time to bring in the 2/13. And we can start solving. I'm going to multiply by both denominators, so they're going to both come upstairs and onto the other side. And then I'm going to expand the left-hand side. And then I'm going to put all terms on the left-hand side, set equal to 0, and you'll see that we have a disguised quadratic. So you can do a substitution at this point, y equals e to the 2x. But actually what I've done here is I've just decided to factorise it in situ, because I spotted what it was going to factorise to quite quickly. Which gives us two possible results: e to the power 2x equals a sixth, and e to the power 2x equals 2. If you take logs of both sides of the left, this equation here, you get 2x equals ln a sixth. And if you work that out on a calculator, you get x is a negative number. But let's go all the way back to the beginning and spot that x has to be positive, or 0. So the fact that this gives us a negative number means that that's not a solution to our equation. So I'm going to use that fun word, disregard, to tell the examiner that I've acknowledged that this is not a correct solution to our equation. Whereas the other one does give us the right answer. Take logs, 2x equals ln 2, and therefore x equals a half ln 2, and that is the correct answer, and you're done.